This video covers the Exam 1 review for Math 137, page 4. Here we have a rational inequality. We follow the same process that we did for the polynomial inequality, where we have to move all the terms to one side, getting 0 on one side first. So we subtract 3x from both sides and maintaining the direction of the inequality greater than or equal to 0. That tells us that we're going to be looking for where this left side is greater than 0 or equal to 0. So that means we're going to be looking for greater than 0 positives or where it equals 0 the zeros. And so we move all the terms to one side. We get a common denominator there of x plus 1. Which gives us x minus 3x squared minus 3x when we distribute the minus sign across. And so then that gives us negative 3x squared minus 3x divided by, sorry, not minus 3x, minus 2 divided by x plus 1. Now the factoring part tells you where you have these critical numbers. And the numerator, I'm going to factor out a negative x. We factor out the negative x, and we're left with 3x minus 2 divided by x plus 1. So now we say that the key or the critical numbers are where the top equals 0 and now also where the bottom equals 0. And I'm going to designate a difference between these. So where the top equals 0, negative x equals 0 or 3x minus 2 equals 0, and then the bottom, x plus 1 equals 0. This one gives us x equals 0, and this one gives us 2/3. So the top's critical numbers are 0 and 2/3. And now that I look back over this again, I realized that when I factored out this negative, I made a mistake, and that should be a plus 2. So that just changes that to a negative 2/3. And the bottom is equal to 0 when x is negative 1. Now, because of the domain of this left side, x plus 1 in the bottom means that x can't be negative 1. We're going to put an x to denote that this is not really a place where it's 0 like the numerators are zeros. Okay, so that's the designation between these two. So now we draw a number line. And placing these numbers on this number line, in order. We have negative 1, and then comes the negative 2/3, and then comes the 0. So now we need to label our intervals from negative infinity to negative 1, from negative 1 to negative 2/3, negative 2/3 to 0, and 0 to infinity. And now we choose test points. From negative infinity to negative 1, a good test point is going to be negative 2. From negative 1 to negative 2/3. I'm thinking of this one as negative 6/6, and thinking of this one as negative 4/6. So a good test point would be negative 5/6. In this interval, from negative 2/3 to 0, negative 1/3 will be a good point. And from 0 to infinity, we can use 1. So now we take those test points and plug it into each one of our factors and determine if it's positive or negative. And then by the product and division of all of them will determine the final sign of our expression in these intervals. And so if we plug in negative 2 to a negative x, and then a 3x plus 2, and then an x plus 1. Okay, negative 2, the opposite of x. Negative x is negative 2 is positive 2 or positive. Negative 2 times 3 is negative 6 plus 2 is negative 4, that's negative. And negative 2 plus 1 is negative 1, so that's negative. And 2 negatives and 1 positive turns into positive. Now plugging in negative 5/6, the opposite of negative 5/6 is 5/6. Negative 5/6 times 3 is negative 5/2 plus 2. Negative 5/2 is negative 2.5 plus 2 is going to be a negative. Negative 5/6 plus 1, that's going to be a positive. So positive, negative, and a positive is negative. Negative 1/3, the opposite of negative 1/3 is positive 1/3, which is positive. 3 times negative 1/3 is negative 1 plus 2 is positive. X plus 1, negative 1/3 plus 1 is positive. That's 3 positives, makes it positive. And the last one, the opposite of x, if x is 1, is negative 1, which is a negative. 3 times 1 plus 2 is 5, that's positive. And 1 plus 1 is 2, and that's positive. So 1 negative makes a negative. So we remember that we were asking for when negative x times 3x plus 2 divided by x plus 1 is greater than or equal to 0. Let's go back up into our interval. We know that it's all positive on this interval, then it goes to negative, then it goes back to positive, and then it goes to negative. We're looking for where it's greater than or equal to 0. So it's greater than 0 from negative infinity to negative 1, and from negative 2/3 to 0. It's greater than 0 in those intervals. But where does it equal 0? Remember, it only equals 0 at 0 and negative 2/3. It does not equal 0 at negative 1, because if you plug that in, At -1, you're going to get the 0 in the denominator, which is undefined. So our interval is from -infinity to -1, but not including it, and then from -2/3 to 0 and including that. So from -infinity to -1, but not including that endpoint, from -2/3 to 0, including both of those intervals. So be careful on these ones. You don't always include the endpoints because you can't include the spots where the denominator is equal to 0. The next set of problems talks about absolute value inequalities. We treat these pretty similar to the absolute value equations, where we dropped the absolute value bars and left it all the same, dropped them, flipped, and taken opposite. With these, because the distance being an absolute value is less than some number, these are going to point to the insides, and so we use an AND statement on this. So 8x minus 5 will be less than 3, and 8x minus 5 will be greater than -3. Then we solve those two inequalities, and we expect for the intervals to point to the insides, as opposed to B, when they point to the outsides because distances are larger than some number, drop them, keep the absolute, drop the absolute value bar, keep everything the same, drop them, flip, and take an opposite. This one is the or statement, because when they point to the outsides, you're either on this side or that side. Adding 5 to both sides gives us 8, or x is less than 1. Adding 5 to both sides, giving us x is greater than 1/4. That I'm going to have to blow up a little bit because 1/4 is just barely. To the right of 0 there. So that's an AND statement. And then in interval notation, we have the left side 1/4 to the right side 1. Not using brackets on this one, just using parentheses. And notice again how they're pointing to the insides. Here we subtract 3 from both sides. 12 minus 3 is 9. Or x is greater than or equal to 9/8, so just a little bit to the right of 1. Subtracting 3 from both sides, giving us -15, and dividing by 8. That is -1 7/8, so that's pretty close to -2, but on the other side here. There's my -15/8. There's my 9/8. But again, notice how they're pointing to the outsides. So you're either on the left or you're on the right. These are two disjoint intervals. So when we write the interval notation, we go -infinity to -15/8 union 9/8 to +infinity. So that's what we call the solution set in interval notation. And this concludes the video for the Exam 1 review for Math 137, page 4.